Hello, and you're once again welcome to Immersive Constructions, where we discuss all things engineering, architecture, and 3D modeling. In our last tutorial, we were able to work on this architectural floor plan and we were able to draw all partition walls. So today, what we want to do is we want to draw the doors and the windows. Then we will be drawing a hatch here. That will end our scope for today's tutorial, and in our next tutorial we'll be adding the room names and also drawing the dimensions. But now what we want to do is we want to create the windows and we want to also insert the windows and the doors. And then the hatch. Now for the window, I'll be using a block that I created, which is located in my library. In case you need blocks for doors, windows, and other uses, you can simply download them on AutoCAD block.com. There are some really nice and cool blocks there that you may enjoy using, especially for doors, windows, and other finishes. So I'll be choosing a block that I personally created for the window. It's however a dynamic block. In case you don't know what a dynamic block is, it is simply a block that is interactive by design and editable in use. Now let's try to insert the block. We can insert the window by choosing this window. This window is actually a 1200 by 1200 window and also a dynamic block. We can place the window like this. We can take it again and move it to fit into the corner of the wall as shown. However, when you look at the drawing, you see that the window isn't on that edge and we need to adjust that. And while the window is 1200 mm, it is offsetted from the edge by 900 mm, which means from here it is going to be offsetted by 900 minus 225. Then we have 450 and another window of 1200, implying that we can subtract 225 from 900 to get the distance of the window from the edge of the wall. Now the distance as shown is 675 mm, and we can simply move the window by that value. Now to draw the other window, we can simply copy the first and paste at a distance of 1200 plus 450 away from the first window as shown. So we'll be moving it by a total of 1650, picking our reference from the end of the first window as shown. Then we try to measure the dimension and position of our windows to see if they correlate with the existing plan, and as you can see, it's perfect. This also helps us to ensure that errors are eliminated and not compounded in our drawing. And as you can see, 450 between both windows is exactly what we have on our existing plan. Now we want to create this 700 toilet window, and as you can see on the existing plan, it's flushed with the wall. We have this block which is actually dynamic, and that's why you see the arrows and points on it. They indicate the points of reference for adjusting or manipulating the block to required measurement and orientation. In order to draw this window, we can simply copy any of the drawn windows and move to the edge of the wall as shown. The window, however, is 1200 and what we need is 700. Hence, to make it fit the required dimension, we can simply click on the distance arrow and drag it back by 700 as shown, and we can also check to ensure that our dimension is indeed accurate. Standard blocks are not easily editable as shown, and the reason we're able to edit this block is because it is a dynamic block. However, you can always turn your standard block into dynamic blocks in the block editor. We once made a tutorial on creating dynamic blocks and currently using the window from that tutorial in this tutorial. And in case you missed that tutorial and ran into this, you may check out the link to the previous tutorial in the description. Now we can proceed to replicate all the windows on the existing plan, starting with windows with similar orientation as shown. Now for the window right here, we can see that it is at a distance of 1425 away from the wall and equally a 1200 window. However, before all else, we can move the construction line behind to prevent it from obstructing the view of our block wall. Now, in order to draw the window, we can simply copy any of the 1200 windows and move to the edge of the wall as shown. Given that it is a dynamic block with a flip parameter, we can simply flip it to fit into the required orientation by clicking the flip parameter. We can now move it to the required position either by moving it to the edge of the wall as shown and subtracting 225 from 1425, or simply move it by 1425 without moving it to the edge as it was done initially. You can simply repeat procedures as required for all windows in the architectural plan as shown. Now that we are done with the windows at the edges, we can draw the windows on the sides by copying a drawn window. And since they are arranged of the same orientation, we can use the rotate parameter on the dynamic block to adjust the rotation. It is important to note that the rotation parameter may fumble the orientation of other parameters on the dynamic block. Hence, you may simply rotate your block manually and obtain the same result without the drawbacks of rotate parameter. Now we can move this to the required location, and in this case I'm comfortable with the functionality of my rotate parameter. Now that we have all the windows drawn, we can proceed to draw our doors by creating or selecting a door block as shown. This is a 1200 door and you can click and install on the plan as shown. Now this seems to have a different orientation other than what we need, but we can simply use the mirror tool to fix that. Apply the mirror tool to the door to create a mirrored duplicate and press enter, then delete the older door and work with the new door. Now we can go on to draw the arch for the balcony. In order to draw a arch, we need a separate unit of enclosed 2D geometry as shown. You can simply collapse this line and create a separate rectangle for the balcony to have it perfectly enclosed as required. Then we can select all the lines in our rectangle and join them to form a polyline which will form the boundary of the arch. We can see from the existing drawing that a portion of the balcony area was the stair and we need to subtract that. The length of the area is given as 900, implying that each stair is 300. We can move this line up by 900 and draw the stairs. Now, instead of us drawing the lines again, we can simply select all lines and join to make a polyline. Then copy to duplicate the polylines as shown. Now, the area right here is where we are going to be drawing a hatch. In order to draw a hatch, you can click on the hatch icon as shown. Then you can select from any of the available options by scrolling down. Now it may appear as shown. When you select a hatch, however, to fix this, we need to edit the density of the hatch. Transparency can be set to 70, and here is where you control the density, and the higher the value, the less dense your hatch. So we can set it to 45 and you can see the result as shown. We can then go ahead to close the hatch panel as shown, and here you can see we have drawn the hatch and the steps, and we've successfully replicated on our 2D architectural plan the doors and windows as drawn in the existing plan. This is all for today, and we hope that you were able to learn a thing or two. Don't forget to subscribe to our channel for more contents like this, and turn on your notification bell to be first to see our latest videos. Thanks for watching, and bye for now.